Hi everybody. Well, let's begin our discussion over the questions from limits. Coming up next is this particular limit, which is limit x tending to 1 from the negative root pi minus root over 2 sine inverse x whole upon root over 1 minus x. Now try to observe this carefully. The function whose limit we need to evaluate at 1 from the left hand side. Here if you recall the sine inverse graph, as x approaches to 1 from the negative, this approaches where? Recall the graph of sine inverse x. It's like this is minus 1, 1, minus pi by 2, pi by 2. Okay, if x approaches to 1 from the negative, sine inverse x approaches to pi by 2. So if this approaches to pi by 2, 2 into pi by 2 gives you pi, so you get root over pi over here. Root pi minus root pi is 0. And as x approaches to 1 from the negative, then 1 minus x approaches to 0. So root 0 is again 0. So actually over here the form is 0 by 0 form, which eventually leads you to recall the L'Hopital rule. Either you can apply L'Hopital rule, okay, or always the moment you see square roots coming into picture, the very natural thing which pops up is rationalization. Okay, so let us try to use rationalization over here rather than L'Hopital, because that is going to be pretty nice in the computation process. So let's actually begin rationalizing. This will be limit x tends to 1 from the negative root pi minus root over 2 sine inverse x whole upon root over 1 minus x multiplied by, what are you going to do? You're going to multiply by root pi plus root over 2 sine inverse x and divide by root pi plus root over 2 sine inverse x. That's what we do. Now a minus b into a plus b is a square minus b square. So root pi square is pi minus root over 2 sine inverse whole square is 2 sine inverse x. Fine. Whole upon, this becomes what? Root over 1 minus x multiplied by root pi plus root over 2 sine inverse x. And this we have to evaluate the limit as x approaches to 1 from the negative. Now try to analyze one thing. You know that limit of the quotient is quotient of individual limits and limit of the product is product of individual limits, provided these individual limits exist. So if I talk about the denominator, right now I can say what? Limit x tends to 1 from the negative of the numerator upon limit x tends to 1 from the negative for the denominator. If you focus upon this expression, when limit will individually be coming over here, what are you going to get? See, individually if you see limit x tends to 1 from the negative root pi plus root over 2 sine inverse x. This will be root pi because limit of a constant is that constant only, plus limit x tending to 1 from the negative root over 2 sine inverse x. Now I just told you as x approaches to 1 from the negative, sine inverse x approaches to pi by 2. So 2 sine inverse x will approach to 2 pi by 2, which is pi. So here you will get root pi already, and from here you will get another root pi. So this is 2 root pi. So for simplification, if you don't want to carry this expression forward, writing it again and again and again, you can over here evaluate its limit as x approaches to minus 1 and keep on writing 2 root pi instead of root pi plus root over 2 sine inverse x. So I'll do that. Of course, this step can be done at the end also, but that is going to lead me to write this expression, this big expression again and again. So just to avoid that, for computation simplification, I will be writing what? 2 root pi in place of this. So what is this going to give me? Limit x approaches to 1 from the negative, in the denominator I write root over 1 minus x into 2 root pi. Now, if you can look at the numerator and recall something, if you can recall the identity which connect sin inverse x and cos inverse x with the help of pi by 2, you will be able to recall that sin inverse x plus cos inverse x is pi by 2. So, pi by 2 minus sin inverse x will be cos inverse x. So, just to create that pi by 2 over here and to get rid of this 2, I will take out 2 common from the numerator. I will be left with pi by 2 minus sin inverse x. Something very direct to click after this step. Okay, it's pi minus 2 sin inverse x. If you take out 2 common, you will get pi by 2 minus sin inverse x, which is cos inverse x. So, this 2 gets cancelled out. You are left with limit x approaches to 1 from the negative. Pi by 2 minus sin inverse x gives you cos inverse x whole upon root pi into root over 1 minus x. Now, the moment you reach this stage, a simple substitution is going to solve all your problems. Just a simple substitution will solve all your problems. You can see cos inverse x over here, you can see root over 1 minus x over here. If I take cos inverse x as theta, I will get x equals cos theta. So, what will my expression become? Limit x tends to 1 from the negative, theta upon root pi will remain as it is, root over 1 minus cos theta. Now see, try to see one thing very carefully. What will be root over 1 minus cos theta? What will be root over 1 minus cos theta? 1 minus cos 2 theta is 2 sine squared theta by 2. So 1 minus cos of an angle is twice of sine square half of that angle. Right? So root 2 comes out and root over sine square theta by 2 is mod of sine theta by 2. But if you carefully see, if x is approaching to 1 from the negative, theta will approach to 0 from the positive if I talk about this expression. Just try to see this. If you recall the graph of cos, this is 0, pi by 2, pi, minus 1, 1. I am saying if x is approaching to 1 from the negative, cos inverse x will approach to 0 from the positive. Or let me say when theta will approach to 0 from the positive, then cos theta will approach to 1 from the negative. You can see if theta will approach to 0 from the positive, then cos theta will approach to 1 from the negative, from the left hand side. So, its opposite is going to happen with cos inverse x. If you draw the graph of cos inverse x, you will see that if x is approaching to 1 from the negative, then cos inverse x will be approaching to 0 from the positive. So, if theta is approaching to 0, x is approaching to 1 from the negative implies theta is approaching to 0 from the positive. So, obviously theta by 2 will also approach to 0 from the positive. That means theta by 2 is an angle which is very close to 0 to the right of 0 but not equal to 0. So, if theta is very close to 0 to the right of 0 and I recall the graph of sine, then theta is somewhere here, very close to 0 to the right of 0. For that theta by 2, theta is also somewhere here, theta by 2 is also somewhere here. So, for that theta by 2, sine is positive. If the angle is to the right of 0, very close to 0, not equal to 0, then sine of that angle is strictly positive. So, if theta by 2 is very close to 0 to the right of 0, then sine theta by 2 is strictly positive, and so there is no requirement to put this mod sign. Okay, just realize this, there is no requirement to put this mod sign. So, you will get what over here? This will be limit x tends to 1 from the negative, theta upon root pi, this will be root 2 sine theta by 2. The moment you look at root pi and root 2, you know they are constants, they can be pulled out of the limit sign. If you pull them out of the limit sign, you will be getting 1 by root 2 into root pi. Inside you have what? Inside you have theta upon sine theta by 2. If you recall this, limit, this becomes x tends to 0, sin x by x is 1, or I can say limit x tends to 0, x upon sin x is also 1, right? Here you can see I have theta upon sin theta by 2. So, theta upon sin theta by 2, something needs to be done to get to this expression. Whatever is in the numerator, same should be the argument of sine in the denominator. So if numerator has theta, this should also have theta, or if this is theta by 2, even here I want theta by 2. So I will create theta by 2 by dividing by 2 and multiplying by 2. So I will be left with 2 theta by 2 upon sine theta by 2. This 2 can be pulled out because it is a constant. And now just try to match this expression. Theta by 2 upon sine theta by 2, where theta by 2 should tend to 0. I know that if x is approaching to 1, theta by 2 is tending to 0. So this entire thing is matching this entire thing, that limit of something tending to 0 of that something upon sine of that something. So that something right now is theta by 2. Theta by 2 upon sine theta by 2, limit theta by 2 tends to 0. So I can rub x tends to 1 minus and write theta by 2 tends to 0, because this is implying this is implying this. So it's one and the same thing. This entire expression, if you understood, is matching this. You can directly write 1 over here. This will be 2 upon root 2 into root pi. 2 upon root 2 gives you root 2 upon root pi into 1, which will be root 2 upon root pi. Beautiful question involving tons of concepts. So if the concepts about functions, about inverse trigonometric functions, about all these limits are clear to you, how one thing implies the other and gets implied by the other, graphs of inverse trigonometric functions are clear to you, this question will be cakewalk, because you will enjoy coming from one step to the other step. Okay, let's try to tackle one of the similar kind of questions in this as well. Now here if you see, the next question tries to say what? Just try to analyze the question, get its demand, and then we are going to deal it with that demand and get to the solution. It is giving us what? It is saying you need to evaluate limit x tends to pi by 4. So the angle involved is pi by 4. You have cot cube x minus tan x whole upon cos of x plus pi by 4 dx, not dx, is. So this is the limit we need to evaluate. So over here, if you try to see x tends to pi by 4 is written over here. If you move ahead with pi by 4 plus h, pi by 4 minus h type of approach, if you move towards pi by 4 plus h or pi by 4 minus h type of approach, that means LHL, RHL evaluation, then you can clearly see x will be replaced by pi by 4 plus h, this will be replaced by pi by 4 plus h or pi by 4 minus h. Evaluating all of that would be pretty troublesome, because we are not getting some simplified expression after that step. So it's really not that logical or rational basically to move towards RHL, LHL approach, right? Apart from this, if you can carefully see, then over here what are you getting? If you put x equals pi by 4, x equals pi by 4, you will get 0 in the numerator. In fact, if you put pi by 4 over here in the place of x, you will get cos pi by 2, again 0. So 0 by 0 form is what you are getting. So again the direct implication is L'Hopital rule, which you can always do. But L'Hopital is dicey. Why? Because we don't know how many times it's going to be applied, to reach to the correct answer. So rather than that, and because you're not able to see square root signs over here, so going towards rationalization is not that direct or natural a technique. So the moment I'm seeing cot and tan and with cos also written, my direct implication is to just change everything. Just convert out things. Let's convert out things for simplification. That really always helps. Cot cube x can be written as 1 upon tan cube x. So from cot, when one step conversion is that I am moving towards tan, and after that I will move everything, convert everything towards sine and cos, because already I have the most simplified expression as cos. So in the end everything will be converted to sine and cos. Right now I am moving towards tan, I am changing cot to tan. This will be cot x plus pi by 4. Right. Next step is going to do what? This is 1 minus tan to the power 4x upon tan cube x, just taking out the LCM, nothing else, cos of x plus pi by 4, right? In here, if you carefully see, two things are directly visible. What? One is that I can write this as 1 square minus tan square x whole square, one thing. Secondly, if I talk about this expression, I will never be bothered to change tan cube x into sin and cos. I will try to change this one into sin and cos because I just told you everything in the end needs to be converted to sin and cos because I have the most simplified expression cos over here. But I will not be interested in changing this into sin and cos. Why? Because as I dealt with in the last question, I can write this as limit of the numerator upon limit of the denominator, right? And limit of the product is product of individual limits. So if I apply limit x tends to pi by 4 tan cube x, what will that be? Limit x tends to pi by 4 of tan cube x will be 1 cube, which is 1. Because tan pi by 4 is 1, it is a continuous function. So in here if I say when x is approaching to pi by 4 in minus pi by 2 open interval, tan is a continuous function, right? So limit x tends to pi by 4 of tan cube x is 1 cube, which is 1. So directly in place of this I will write 1. I will not keep on dragging tan cube x in each step after this. So rather than that I will have what? This is limit x tends to pi by 4. After writing this, I can see this is of the form a square minus b square, so a plus b into a minus b. So 1 plus tan square x into 1 minus tan square x. Fine. This is 1, I have already said this will be cos of x plus pi by 4. Again you can clearly see, that what will this be? 1 plus tan square x, limit x tends to pi by 4 of 1 plus tan square x, 1 will remain as it is, and limit x tends to pi by 4 of tan square x will be 1 square, which is 1. So 1 plus 1 will give you 2. I can replace this expression by 2 by assuming limit is already applied over here. This will be 1 minus tan square x whole upon cos of x plus pi by 4. I am not applying x equals pi by 4 over here because this is going to give me 0, and 0 by 0 form is something I am not interested in. So I have applied limit to this expression deliberately because that is not giving me 0, it is giving me a number, that is 2, which I can always take out of the limit. So this will be twice of. Now comes the time to convert everything to sine and cos. So 1 minus tan square x, 1 minus sine square x upon cos square x whole upon cos of x plus pi by 4. See, cos I am not disturbing, in fact I am changing everything to sine and cos. So this will be twice of limit x approaches pi by 4. This is cos square x minus sine square x. Right, in the numerator you have cos square x minus sine square x whole upon cos square x into cos of x plus pi by 4. Okay, now cos square x minus sine square x obviously leads to what? A square minus b square, which is a plus b into a minus b whole upon, this is cos square x, leave it as it is. And here if I talk about cos of x plus pi by 4, you can directly recall the formula cos of a plus b, which is cos a cos b minus sin a sin b. Cool enough? This will be twice of limit x approaches pi by 4 cos x plus sin x into cos x minus sin x whole upon cos square x. And now look over here, what is cos pi by 4? 1 by root 2. So instead of this I can write 1 by root 2, instead of this I can write 1 by root 2. So you will have 1 by root 2 in the product, and here also 1 by root 2 in the product. So 1 by root 2 completely can come out, that root 2 can go above, so I will have root 2 over here, and here I am only going to be left with cos x minus sin x. So cos x minus sin x, cos x minus sin x cancels out. This is 2. Now you have to just apply limit to each expression. Limit x tends to pi by 4 of cos x is 1 by root 2. Limit x tends to pi by 4 of sin x is 1 by root 2. 1 by root 2 plus 1 by root 2 is 2 by root 2, which is root 2. Root 2 into root 2 is 2. Root 2 into root 2 is 2. And what is this? What is this? Limit x tends to pi by 4 of cos square x. That means limit x tends to pi by 4 of cos x whole square. That means 1 by root 2 whole square, which is 1 by 2, which gives you 2 into 2 into 2, which is 8. And that happens to be your answer. Is it clear? I hope the limit evaluation was very nicely understood. Let's move to the next question. The next question is asking us to do what? Again, evaluate limit, but the given conditions are very strong. What is given to you? This is a superb question, great question. It says that let f be a differentiable function. F dash x is given to you x positive and f of 1 is not equal to 4. Then evaluate limit x tends to 0 from the positive x into f of 1 by x. Just look at this. Look at this question, how beautifully it says f dash x is 7 minus 3 by 4 fx upon x. X is positive, that is why it's written in the denominator. Now, in order to calculate f of 1 by x, until and unless I have the expression of f of 1 by x, how can I move ahead with the limit? To have expression of f of 1 by x, I need to have expression of f of x. I will be evaluating f of x from here. How will I be evaluating? I will be treating f of x equals y. So, this will be what? dy by dx, right? This will be 7 minus 3 by 4 y by x. Now, try to see this. This is dy by dx equals, this is fx by x, yeah, okay. So, this is dy by dx plus 3 by 4x into y equals 7. I can write it like this. This is like dy by dx plus py equals q, where p is a function of x and q is a constant term. Isn't this my linear differential equation? Let's solve it. I will be solving it for y, that means I will be solving it for f of x. I will get my expression of f of x, right? Let's first find the integrating factor, which is integration of e to the power integration of p dx, that means 3 by 4x dx. 3 by 4 will come out, integration of 1 by x dx, which is log x, right, which can be written as e to the power ln of x to the power 3 by 4, which is just x to the power 3 by 4. So, my integrating factor is this. So, what will be my solution? Y into integrating factor is equal to integration of q into integrating factor, right? This will be y into x to the power 3 by 4. 7 comes outside, integration of this is x to the power 3 by 4 plus 1, which means 3 plus 4 whole upon 4, which means 7 upon 4 whole upon 7 upon 4. So, this 7 cancels out, plus c, right? So, you will have y into x to the power 3 by 4 equals 4x to the power 7 by 4 plus c. But till now I have not been able to take out my f of x from here. So, let me try to take out my f of x from here. This will be 4 x to the power 7 by 4 upon x to the power 3 by 4. So, 7 by 4 minus 3 by 4. This is what? X to the power 7 by 4 upon x to the power 3 by 4 plus c upon x to the power 3 by 4. This is what you are getting. I can write x in the denominator because it is given to be positive. So, what will I have as my f of x? Y is same as f of x. This will be 4 x to the power 7 by 4 minus 3 by 4. That means x to the power 4 by 4, which is 1. So, x to the power 1 plus c upon x to the power 3 by 4. This is my f of x. I have to evaluate the limit x tends to 0 from the positive of x into f of 1 by x. So, I need to evaluate f of 1 by x first of all. F of 1 by x I have to evaluate. But one thing, let me tell you one thing, f of 1 is not equal to 4. Try to get this, f of 1 is not equal to 4. That means when x is equal to 1, y is not equal to 4, y is same as f of x. Let's see. What is y when x is equal to 1? When x is 1, you get 4 plus c as f of x. It's not equal to 4 means 4 plus c is not equal to 4 implies c is not equal to 0. The question is trying to give you this. When x is 1, y is not equal to 4 means when you put x equals 1, then c is not equal to 0. The constant of integration is a non-zero constant. You don't know what is c, right? You don't have the exact value of c. But one thing the question is trying to give you, that it is a non-zero constant. I need to now evaluate from f of x, f of 1 by x. So this will be 4 by x plus this will be what? C whole upon 1 upon x to the power 3 by 4, which becomes what? 4 by x plus c x to the power 3 by 4. This is f of 1 by x. Now I need to evaluate what? I need to evaluate the limit of x into f of 1 by x. So limit when x tends to 0 from the positive, x into f of 1 by x, which is limit x tends to 0 from the positive, x into what is f of 1 by x? This is 4 by x, and here you replaced x by 1 by x, so c divided by 1 by x to the power 3 by 4 is c multiplied by x to the power 3 by 4. So this will be 4 by x plus c x to the power 3 by 4. This will be what? Limit x tends to 0 from the positive. That means x is a positive number, very close to 0 from the right. This x will be cancelled out. This will be 4 plus c x to the power 3 by 4 plus 1. That means you have 4 plus c x to the power 7 by 4. This limit you have to evaluate. And now something very obvious happens. You will be wondering, what is the point of us knowing that this c is not equal to 0? What is the point of us knowing that c is not equal to 0? The point of us knowing that c is not equal to 0 is that you can write this as like this. Now, the fact that c is not equal to 0 means that I can take this c first of all outside. It is a non-zero constant. It is a non-zero constant. If it would have been 0, then first of all I would have got 0 into 0 type of an expression, because x is also approaching to 0. It is a non-zero constant. I can take that out very easily. I will be left with limit x tends to 0 of x to the power 7 by 4. X to the power 7 by 4 is a polynomial function, and polynomial function is continuous. Limit of a polynomial function at a point is value of that polynomial function at that point. So limit of this polynomial function at 0 is value of that polynomial function at 0, which is 0 to the power 7 by 4, which is 0. So you get c into 0 plus limit of a constant is that constant only, be it at any point. So this will be 4 plus 0, which is 4. So you evaluated limit of this expression with this condition kept in mind and with this condition kept in mind, and you are getting that limit as 4. Is it clear? We're going to begin with problems from integration in the next lecture. So I'll see you then. Revise these very nicely. That's it from my side. Thank you.